Hello again. We continue to the specification of ISE model. The ISE model performs potentiometric analysis, sodium, potassium, and chloride, and is either one or two ISE units. Basically, this section I will talk about general specification of ISE model, list of sample and reagent biometric volumes of ISE model, list of measuring ranges of ISE model. This is the machine, and this is general specifications. The application is three ions, sodium, potassium chloride, and samples can range from serum, cerebral fluid, and others. And you can pause this this slide and read everything. It's just self-explanatory. I don't have to waste time. Then this is sample reagent and biometric volume of ISE model. And this also explains first run and second run, and still is self-explanatory, and you can read the volumes and dilutions. Um, and last, this is where the doctors look at, and so this is the range, like sodium is 80 to 180. So is the numbers, you can look at it. And so overview of ISE analysis flow. Um, its ISE measurement required consists of two individual processes. One is measuring of ISE reference electrode, and the other is at the three electrodes. So don't be scared. I will explain each one. This is consists of 7 sections. So A, B, C, D, E, F, G. So I will go first. Let us start with A. Before I go to A, let me define two words. Aspirate means matters that's been drawn from the body of, basically is taking a liquid from some place to another place. Dispense is releasing, is just sucking, and dispense is releasing. Okay, A is this section, this section A, and it's called liquid mixing components. It consists of 4 nozzles, 2 fixed and 2 movable nozzles. These are 2 fixed are from diluent and ISE standards, and 2 other I also is one is for taking mixed sample to the electrodes, and the second is to go into the west. And this is the second one. This is the measuring this whole. This is measuring component. So this is consists of 3 ion specific electrodes and 1 reference electrode. And this is what I'm about to say is the most important thing. The measurement is based on determining the voltage between reference electrode and individual ion specific electron. The resulting signal is processed by the control unit. The control unit means this thing is attached to the computer, and that's what feed to the computer, to your screen. And let's move on. So there, everything is heated. The heating section is this one. This area, everything is heated before it went to the mixing vessel. So several heating elements ensure the correct temperature of reagent before entering the dilution. So let's move on. Liquid waste component. This is this one. You see these, all these go in here. The waste goes here, this section. Let's move on. E is syringes used to transport reagent and sample. Each has its own syringe. Okay, I will talk about this one. This one is So the three syringes, the syringes has the gassed water, and this one is a diluent. This one is the some I mean ISC and I internal standards, and this is the reference. So each one has storage. So we'll go next is the storage, the degassing I talked about. So liquid storage. So it's reference, diluent, and internal standard. So let us go to the. So this is standard. So the standard goes here, and the diluent goes here to the syringe and then goes all the way to the mixing, and also standard goes to the standard syringe and then goes to the mixing. So let us go to the principles. So the principles will be how the machine runs. So this is overview preparation, the initial standard measurement. So the before the sample, the standard has to be done, and then the sample is diluted and that's measured, and then another standard measurement is happened to to create. So we'll go over one by one. So let us go first. So the beginning measurement standard nozzle, I mean, is first is cleaned, and this is the reagent used for IC measurement. This is internal standard and reference, and also dilute. Those three things are used to measure ISC. Second step is before measuring dilute sample, ISC measurement is performed and is internal standard, and each electron is measured against ISC reference electrode in the reference electrode. So what that means is, let me go back here. Okay, yeah. What that means, so this one is drawn from here, going through the syringe and went through here and will go through here, while this one is going through here. And then is, is the voltage is measured and the computer displays it. I mean, keeps in mind that that's the standard. And the standard nozzle dispenses internal statin into the dilution vessel. The standard nozzle sprays the internal statin from dilution vessel to the IC electrodes. The zebra syringe aspirates reference into the reference electrode. The voltage between ISE electrode and reference electrode is measured. The vacuum aspirates the remaining IC instead from. So it has to be vacuumed. So the sample is coming. Now the standard is done. The sample is coming. So the diluted sample of the IC electron is measured against reference this time. The standard is done. So now the sample itself is coming to the diluted vessel. So Bybetter uses 10 or 15 sample into the dilution vessel, and the diluent supply nozzle also 450. So this means is, now this time is, so this is 300 is taken from 450, went to the syringe and brought it here, and sample serum, whatever it is, and are mixed to and then is fed to the electrode. That's what it's saying here, step 3. So let us say it again. The sample Bybetter dispenses R15 or sample into the dilution vessel. The IC diluent supply nozzle dispenses 450 of diluent into the dilution vessel. They're both in, so 15 plus 450 or whatever are, or 10. Also, and it's mixed, and then zebra aspirates diluent sample into the electrode. Then this is fixed into the electrode. The zebra syringe also reference use 130 reference electrode, and then uses this this is again is coming from here. So this one is coming from here. While the sample and dilution are mixed here, this one is going to here, and this one is fed in here, and that one is fed here, and it's the voltage between them that the computer is fed, and that's what the result are. So let's move on. Number 3, yeah. So the voltage between ISE electron and reference electron is measured and calculated into the ion concentration vacuum nozzle aspirates remaining dilution sample from the dilution ratio, and it's vacuumed again, and then after measuring diluted sample and another IC is measured to perform to correct any drift in the voltage. Of example, due to difference between electron concentration if another nozzle is measured. So basically it has to be adjusted, the step 4 is to adjust, to get back to normal. So if you understand this flow, this preparation is like vacuum and all, and first is initial standard measurement, then measuring diluted sample, then back to the standard measurement. So what it's doing, let us go to the diagram. So this is what this is let me go back. Yeah, when you take the cover out of this machine, that's what this is, and this is the flow. The first, let me say it again. First, you take this through this string and then goes here, and then this one goes here, and then is this one is the one that's from here is fed to here, and this one from here, and then the voltage is fed to the computer, and the computer gets into the memory. Then is vacuumed, is cleaned, everything. Then the sample comes here, and then diluent like 450 and 15 are mixed here. Heating and also degassing is on the process in it. So then it's fed here, and reference also again is fed here, and then the voltage difference is fed to the computer, and that's what actually is result. That's what the result. So and that's it for me, the second video. I'll stop here.